Hi, and welcome to the second video in the Deephaven Learn series. In this installment, we'll cover the Gather Compute Scatter paradigm. Deephaven Learn was built using a Gather Compute Scatter paradigm. That means that when using Deephaven Learn, you can create powerful queries by following its principal design concept. 1. Gather table data into one or more Python objects of your choosing. 2. Perform computations on the gathered data. And 3. Scatter results back into a resultant table. This paradigm is a popular design concept in modern data processing software architecture. Incoming data streams are rarely presented in a format that is conducive to the technology being used to perform analysis on it. Thus, the need for gathering raw data into an acceptable format becomes readily apparent. In the case of Deephaven Learn, the gather step takes a specified subset of rows and columns of raw table data and converts them into a two-dimensional NumPy array, which can then be transformed into a different Python object if necessary. The compute step is where you get to do the most fun part: process your gathered data. Deephaven Learn is agnostic to what you do with the data once it's been gathered. So go ahead and train a neural network with PyTorch or TensorFlow, fit an unsupervised model with scikit-learn, smooth noisy data with SciPy, perform data windowing with NumPy, or really anything else that you can think of. It's at this step where the magic happens. And the magic happens both statically and with dynamic real-time data. Lastly, there's the scatter operation. Deephaven Learn allows you to decide how you want results to be displayed. It's the final piece of the puzzle when creating data science, AI, and ML solutions. I'll be covering each component of this design concept in a later video in this series. In those subsequent videos, I'll go into greater detail on how each piece of this puzzle works in practice. Here's a list of supported data types for gathering and scattering in Deephaven. We support 8, 16, 32, and 64-bit signed integers. We also support 32 and 64-bit floating point precision values. This list will continue to grow in the future, with current plans to support Boolean values in Python as well as string values in both. Thanks for watching this video. In the next video in the series, I'll cover the gather step in greater detail. Later on, I'll cover the compute and scatter steps as well. Once those are complete, it will all come together with the learn function call. If you enjoyed this video, check out the others in the series. Additionally, consider liking and subscribing to our channel for new content that includes examples, demos, guides, and other relevant content. See you in the next video in the series.